Have a look at this example that I show over here. Okay, first of all, let me check your knowledge. Sharon, do you think the alkene molecule that I draw over there has cis and trans?
No,
Okay, why?
because on one carbon, there's like the same functional group.
Yes, okay, the carbon that is attached to the double bond, they have the same functional group. Okay, therefore they don't have any geometrical isomerism. Now, I want to add this with HBr. Condition will be this is going to be concentrated HBr and it is done at room temperature. Okay, so when I do this, I will have two situations over here. Two products will be formed. Okay, let me tell you why two products will be formed. You are going to break the double bond, okay, and then you are going to get CH3, CH3, H and H. The double bond is going to be broken, so I'll just write down first. But there will be a situation where you need this HBr, okay, the H can come over here, then you put the Br over there. Or you will have a situation where the BR comes here and H is put over there. I just want to just double check this with you guys. Frederick, do you think, okay, do you think molecule A and molecule B, they are the same?
They're different.
Okay, they are different. So let's try to name them. Okay, I think the best way to differentiate them is to name them. Okay, so let's try to name them. Okay, the longest carbon chain that I have over here is going to be 3. Okay, 3 carbon chain. So this is going to be if you use the flop method, functional group. So this is all alkane. So this is going to be propane. Okay, propane. And then the longest carbon chain we found out, okay, 3. So then we are going to look into the group, okay, the position of the group as well. Okay, so if you look over there, there is bromo and there is also methyl. Okay, and then the position, okay, you can have this is 1, this is 2. Okay, so here I will rather use position 1 for bromo, position 2 for methyl. Okay, so let's say I'm going to use 1 bromo, 2 methyl propane. Okay, this is going to be the name. So let's do the same thing over here. The longest carbon chain is this one. Okay, and then you can see this is going to be the branch. Okay, bromo and methyl, but they are at position number 2, carbon number 2. So this is going to be propane as well, but this is going to be 2 bromo, 2 methyl. So you can see they are different. I think that is what I want to show you. They are different. So now I just want to ask you, whenever you have this reaction, yes, we do have a mixture of product. I want to ask, okay, whether this mixture, is it going to be 50%, 50%, or do you think that you will have a concept which is going to be major product or minor product? It means there will be higher percentage of this particular product compared to the other product. So what do you think, even? Do you think it's going to be equally formed, 50%, 50%, or do you think it's going to be slightly different, even?
So I don't understand what you mean by like 50%, 50%.
Okay, you see here, I told you that when this HBr reacts with this molecule, right? This H can either go to this position or this H can go to this position. It means you are able to form 1 bromo 2 methylpropane and 2 bromo 2 methylpropane, which are two different things. It's a mixture. So my question is, when you form this mixture, is this going to be 50% of this and 50% of this? Or is it going to be having a different ratio even? Which one do you think?
Same.
So you think it's same, okay? Now, This one, okay, will not be the same. And there is a reason. Okay, I think normally when we look at it in just this question alone, then we think it's going to be the same. But we will have major product and minor product, okay, which is going to be related to what we have learned earlier. Okay, let me recall this for you guys. Okay, you see we have learned about, okay, this carbocations. Okay, if you have R, okay, 3R groups, and if I have 2R groups, carbocation, and if I have only 1R group, okay, carbocation. Can you remember, okay, which one? I know this is 1R group is primary carbocation, secondary carbocation, and tertiary carbocation. We have already learned about this. But I just want to ask you which one is more stable. Josh, can you remember? Which one is going to be more stable? Tertiary, secondary, or primary?
Tertiary.
Why? Do you guys remember, okay, about what is the function of R group, okay, the alkyl group? The alkyl group has the tendency to push the electron. It means the tendency to donate the electron. So when the electron goes in, when the electron goes in, when the electron goes in, what happens, okay, is going to be the positive charge, okay, of that carbon is going to be decreased. Okay, it's going to be decreased. So this is going to make what we call as a positive inductive effect. If you forget about this, I'm very sure you will remember the example that I gave you. If you have only one person trying to share when you are broke up, okay, and then you're trying to share it to one person, yeah, the positive inductive effect is not that strong. But if you happen to share it with 3 people, and then maybe there is more positive inductive effect because the charges is being spread across, okay, 3 people, or your sadness is going to be decreased way more. So I told you, if you only don't have enough support, then the person will commit suicide or something. I put in that diagram. Okay, this will be helpful over here. Why? Because tertiary carbocation is more stable, or when we say more stable, it is favorable. Okay, it is going to be formed more. Okay, it is going to be formed more. Okay, compared to primary carbocation. So when you form tertiary more, okay, the one that is more stable, of course you are going to have more component, okay, related to that. So now I want you to relate to what we have over here. Okay, if you relate to what we have over here, okay, if I put the carbocation, it's very difficult to look at it in this form. Okay, why? Okay, because I do not know what is the carbocation, but okay, if we try to redraw this again, okay, when I have this situation, okay, so the carbocation, the electrophile, okay, is going to be the H plus. So in this example, the H plus came here. Okay, the H plus came here. So left with the Br minus dot dot. So what I'm going to do, I'm just going to go one step before that. Okay, one step before that. And this is going to be the carbocation. The same thing, I'm going to do the same thing here. Okay, the H plus is the electrophile. So the H plus came here. So you will have the Br minus dot dot. So before that, this thing is being formed. Okay, I'm just going to go behind one step and I'm going to have this. So now it's going to be easier to see. There is a carbocation. Both of them, there are different kind of carbocation. And if you look at that, okay, carbocation, this carbocation, they only have one R group. Okay, only one R group. This entire thing is one R group. And if you look at this carbocation, one R group, another R group, another R group. So you can see clearly that this is going to form tertiary carbocation, and this is going to form primary carbocation. And I already mentioned which one is more stable. Tertiary is more stable because more positive inductive effect. So if tertiary is more stable, what we are going to get? We are going to get 2-bromo, 2-methyl propane more. Okay, so maybe 80% and then maybe 20% only here. Okay, so this is what we call as major product. Explanation is given, okay, but practically how to apply, okay, how to apply it practically. How do I, the moment when I see a particular equation, okay, the moment I see that CH3 CH3 and I have H and H, if I want to react with HOH, how do I see which one is going to be major product, which one is going to be minor product? Okay, to explain that, okay, this one is going to be in the past, okay, the one that we use over here, the positive inductive effect and so on. We classify them into Markovnikoff rule. I'm not going to even write it down over here. They have removed that term, okay, that rule, and represent with the explanation only. Okay, so it's still an application of the rule. Okay, but according to the rule and according to this explanation that I gave, you can simplify this, okay, using Mr. Gopi's rule. Okay, Mr. Gopi's rule is going to be the hydrogen will go to the carbon that has the most hydrogen. Okay, hydrogen will go to the carbon that has the most hydrogen. So let's see how to apply this. Okay, so you see here, or you can see rich become richer or something. I do not know, some students, they like to memorize in that way, but for me, yeah, hydrogen will go to carbon that has the most hydrogen directly attached to it. So you can see here, okay, that this carbon has 2 hydrogen directly attached. And this carbon over here, they do not have any hydrogen directly attached. Okay, it's going to be carbon. So here, what happens is this hydrogen, they will have tendency to go to this carbon. So you just put H, 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 and then CH3, CH3, and then the OH will come. So if they ask you what is going to be the major product, this is my major product. But Mr. Gopi, how to explain? Okay, you are using this method. How to explain? Explanation I already told you earlier. The H will go, okay, to the carbon that has the most hydrogen. It means that, okay, it means that this was my carbocation, okay, before the OH came. If let's say, okay, if let's say the hydrogen went to the carbon that has less hydrogen, then hydrogen will come here. So I'm going to get H, H, and this is going to be by carbocation. And I'm telling that this is minor. Why? You can have a look at, okay, the type of carbocation. Okay, the type of carbocation here is going to be 1, 2, 3, tertiary carbocation. And if you look over here, this is going to be primary carbocation. So automatically the tertiary carbocation is more stable. So this formula that I'm asking you to memorize, okay, is going to be valid. Hydrogen will go to the carbon that has the most hydrogen. Hydrogen, yeah, hydrogen. Okay, so when it comes to it, we will not have the same problem when we are trying to add with H and H or Br and Br, because no, they are still going to give you the same product. But the problem will come, okay, when you are trying to add HCl, HBr, HI, HOH, okay, all this, okay, you are going to have different products, a mixture of products. So you need to tell which one is going to be the major product, which is going to be the minor product. Okay, that is going to be what I wanted to teach you for today. Okay, is there any question up to